All right, we're rolling on to our energy, emission, and air quality session now. And we have a really, really good presentation from Meaghan Atkinson with CSX. And Sarah, I warned you I was going to mispronounce your name, so kick me under the table if I get it wrong. Sarah Elsokkary with Arcadis. Mariana Saldana is also a co-author of this, but I think it's just Meg and Sarah presenting. So again, they're going to talk about establishing a reasonable greenhouse gas emission reduction target at CSX. I know a lot of you know Meg. She's an environmental manager at CSX. She's on CSX's internal environmental compliance review program. She manages the sustainability strategy and communication program there. She manages the compliance of more than 200 water and air permits throughout CSX's 23-state network. She's worked across the company to set sustainability goals, respond to data requests, and she's just an overall quality person. And the best part is she's a Gator. Go Gators. I'm a Gator, by the way, if you couldn't tell. Sarah is an environmental engineer with Arcadis as part of their planning, permitting, and compliance team with a focus on the rail sector. She has 10 years of experience in the environmental compliance field and is currently focused on rail sector sustainability initiatives. So Meg and Sarah, take it away.
Thank you, Kevin. Are you able to hear me? I just want to make sure.
You're crystal clear.
Perfect. Well, thank you very much for that energetic introduction. That's wonderful. We are excited to talk about the work that we've done in the last year to establish a greenhouse gas emissions target at CSX. This is our third generation goal. Sarah, you want to move on? Great. So we're going to go through the emissions timeline and you know, what we've done kind of over the course of the last 10 to 13 years in the greenhouse gas space, the drivers for setting a greenhouse gas emissions reduction target, and specifically why we decided to go with SBT this time. Sarah is going to get into the nitty-gritty of what it is like to go through the SBT process, and then I'll talk a little bit more about the teams internally that we had to kind of get on board and how that effort went. We'll talk about the emission reduction initiatives that we currently have underway and our progress to date, and then we'll be happy to take any questions. So next. So this is kind of a timeline from 2007. CSX began conducting a full greenhouse gas inventory of 2006 data, and we also started a third-party verification in that year. So we have worked over time to get that third-party certification to a reasonable level of assurance, and that's really, I think, improved our confidence in our data. We voluntarily joined the EPA Climate Leaders Program and committed to the first greenhouse gas emissions target, and that was 2006 to 2011. So it was an 8% reduction over 5 years. CSX achieved that goal a year early, and then in 2011 we set the second generation target of 6 to 8% reduction by 2020 from a 2011 baseline. That goal was achieved in 2018, and we started to really research what our next big goal was going to be. And in working with SBT in 2019, we went back and forth several times, but finally got validation on our well below 2 degrees Celsius scenario and received validation very early 2020. So you can see our goal there highlighted in blue. So this is very ambitious to reduce the greenhouse gas emissions intensity by 37% per million gross ton mile by the end of 2029 from a 2014 baseline. So the most ambitious we've ever kind of stated publicly, and certainly a much longer timeline. We did work hard to make the public part of this goal, focused on intensity, although SBT does require that absolute year-over-year reduction that I'm sure Sarah will touch on. So we can go to slide 4. So wanted to talk about some of the drivers for setting a greenhouse gas emission target. From an operations perspective, our Chief Operating Officer and everyone under him are very, very focused on driving emissions and fuel use to the absolute minimum possible. So, optimizing operational practices, this is right in their wheelhouse. And then, of course, increasing the efficiency, lowers operating costs. Beyond that, SBT carries its own weight in terms of our reputation, and so it boosts the credibility of our goal. The first goal that we set was aligned with EPA climate leaders, but then the second goal that we set was just kind of internally benchmarked, and we didn't align with a third party. So this, we felt like, gave a boost of credibility to our goal. Differentiating companies with the best prospect for long-term investment, and of course, getting ahead of regulatory and policy opportunities in the future. Sarah, do you want to get into the goal?
Yes, can everyone hear me?
Yes, we can.
Okay, all right. So I'll start with what is a science-based target. So since the Industrial Revolution, man-made greenhouse gas emissions have increased significantly. And according to the Paris Agreement, at the current rates we're going, it'll raise the Earth's temperature by 4 to 6 degrees by the end of the century, causing extreme weather events. For example, rising sea levels, more intense hurricanes, etc. The Paris Agreement aligns to commit to dramatic reductions in annual greenhouse gas emissions to reduce to a net zero emission by 2050. So in order to meet this ambitious reduction, stakeholders are pushing private sector industries to commit to reductions in line with the current carbon budget. This is currently known as the well below 2 degrees Celsius scenario. This equates to an absolute annual linear emissions reduction of 2.5%. But in the near future, the Science-Based Target Initiative will require a more aggressive carbon budget and only adopt targets aligned with limiting global warming to 1.5 degrees Celsius. That scenario equates to 4.2% reduction annually. So there's two different types of targets. You have your absolute emissions reduction target, where the reduction is in absolute metric tons of CO2 equivalent emissions each year. And then you have the emissions intensity target that Meaghan touched on that CSX has set. And this is your absolute emissions reductions relative to a normalized metric, so such as gross or revenue ton miles for the railroad. An emissions intensity target gives your company the opportunity to factor in projected growth in business over the length of the target. So next, we'll go through the steps in evaluating a science-based target. First, you're going to create a baseline greenhouse gas emissions inventory, importantly, including in identifying your sources for your company, and then developing a methodology for those calculations. Second, you want to select your target year. So Science-Based Target Initiative requires a minimum of a 5-year and a maximum of 15-year target. CSX had a drastic reduction in emissions from 2014 to 2015 and chose to include their historical data to highlight that progress. Although CSX used the historical data, the Science-Based Target Initiative still requires a forward-looking annual linear reduction of 2.5% for approval. And CSX still meets this requirement from 2018 to 2029. Third, you want to project your business as usual emissions. So evaluating trend lines using your historical data over the target period. The more consistent your greenhouse gas inventory data is, like your sources and your methodology, the easier it is to evaluate trend lines and show what initiatives have created the most effective emissions reductions. Fourth, you want to determine the type of reduction target applicable, so the absolute versus your emissions intensity that we discussed previously. Fifth, if you're choosing an emission intensity target, as CSX did, you want to project your business growth over the timeline of your target. The science-based target is based on absolute emissions, like Meaghan kind of touched on. However, depending on the projected growth in your business, you can convert it to an emission intensity target using that projected normalized factor. Last, you want to weigh the potential target levels against the feasibility and cost of prospective action plans. So CSX worked with their fuel strategy and utilization group to determine internal buy-in and then efficiency projections, which Meaghan will touch on a little more. So there's a 4-step process in having your science-based target validated through the Science-Based Target Initiative. The meat of the process includes developing your target and the validation process with the Science-Based Target Initiative. As part of developing your target, you have to do a Scope 3 screening. So you must include your base year and the most recent year Scope 3 data by source. There's 15 different sources that are aligned with your CDP submission that you must submit data on. Your total Scope 3 must not account for more than 40% of your total Scope 1, 2, and 3 emissions, or the target will also have to include Scope 3. CSX's Scope 3 emissions accounted for less than that 40%, so their current target only includes Scope 1 and 2. Once your submittal form is completed and your initial screening is performed to determine if all the criteria is met, there is a lengthy query process, as Meaghan indicated, with the Science-Based Target Initiative, where you go back and forth determining the appropriate and approved target for publishing. And then after validation, the annual progress towards the target is tracked as part of your CDP submittal. So there's 3 different approaches for the science-based target. You have first the sector-based approach, which uses a carbon budget for the transport services sector, including freight rail. And the required emissions reductions are allocated to each individual company based on its sector's budget. This approach uses the sectoral decarbonization approach, or the SDA tool. The second one is the absolute-based approach, which uses absolute contraction and a set of emissions reductions applied equally to all companies. So no matter the sector, each company has to reduce the same amount. The current required well below 2 degrees Celsius ambition is the 2.5% forward-looking annual linear reduction. And then the third approach is the economic-based approach, which is a carbon budget based on your gross domestic product, and a company's share of emissions is determined by its gross profit. So the decision for CSX was between using the sector-based approach and the SDA tool and the absolute-based approach. CSX chose this absolute-based approach because the SDA tool used for the sector-based approach required a more ambition for CSX, in addition to the already ambitious 2.5% annual reduction under the absolute-based approach. So we'll get in here to evaluating the science-based target for CSX and the way they went about that. So once CSX decided on the absolute-based approach, the historical data was evaluated to determine the required ambition. So if you're looking at this chart here, the blue data is their actual historical data. The far right column shows their actual absolute emissions reductions in blue over those 4 or 5 years. And then the forward-looking information in gray shows your 2.5% annual forward-looking. So that equates to 27.6 0.5% by the target year forward-looking, so 2018 to 2029. Using that 2.5% annual reduction, CSX determined the required reduction in absolute emissions estimated from 2019 to 2029. Next, CSX determined their projected growth to determine what the emission intensity would be over the target time frame. And the way that they did this was with the DOT Bureau of Transportation and Federal Highway Administration Freight Analysis Framework. So this framework estimated freight haul growth of 7.1% between 2016 and 2030, and therefore CSX estimated a growth of 0.51% annually. So using that estimated growth, they were able to predict their million gross ton miles, or their normalizing factor, for the years 2019 to 2029, and converted their absolute emissions reduction to the emissions intensity target. All right, I will turn it back over to Meaghan to talk about the CSX internal buy-in.
Thank you, Sarah. So we started having these internal conversations about how to do this goal, and a big part of this was really led by our operations team, and our chief operating officer was very excited about taking some of the things that he was really insisting upon from an operations perspective, and publicizing it and talking about it in this light. So we were very excited to have full executive leadership support of a science-based target. We got into the details with the fuel strategy team, and really felt like we could align the emissions target with the diesel fuel locomotive use, and went through this many times to think about how efficiency is going to change this over time. So our greenhouse gas emissions inventory has been pretty standard, I think, over the last few years, where we have a very strong methodology, and we know that diesel fuel emissions account for an average of 92% of the total corporate annual greenhouse gas emissions inventory. And once we determined the required reduction in absolute emissions, we were able to convert those absolute emissions to the diesel fuel reduction requirement to meet the target. Next, Sarah. So some of the emission reduction initiatives that are currently underway are based in these three kind of pillars. So operations is continuing to reduce asset intensity, reduce dwell time and idling, and eliminate unnecessary stops. Prioritizing certain traffic over others in order to really think about what burns more fuel to get up and running again. They're being very, very thoughtful about this. So in terms of management, there is a new dedicated fuel conservation desk, strict scrutiny of practices to eliminate waste, company culture of improvement, and investment in renewable electricity resources. We did invest in RECs this year and are looking at renewable energy in the future. From a technology perspective, we continue to implement Trip Optimizer across the system. We have a Ytronix remote fuel monitoring, which gets the attention of our engineers very, very quickly if need be. Automatic engine start-stop, and our Meet Pass Plan technology. So these are just some of the things that we are currently doing. We do anticipate that over the next 10 years, there will be transformative technology in the rail space that will create jumps in efficiency that are not being realized at this time.
So last we kind of wanted just to go through the science-based target process, progress that CSX has made from 2014 to current. The way that we track this data currently, to take a look, is through a Power BI dashboard. So the bottom left here of the dashboard, you can see it shows the current emissions reduction improvement using the emission intensity from the base year 2014 to the current year 2019. It shows that CSX has had a 10.74% reduction in emission intensity over that 5-year time period. So if we update these years, we can evaluate any annual reductions or show a specified time range. So CSX had very transformative years between 2017 and 2019. So if we update here, we can kind of focus in on that 2-year time frame to see what their percent reduction was over those initiative years. And as you can see, it was the 6.01%. So if we go up to the top graph here, this is their progress towards their target. So their actual emission intensity and target emission intensity. The blue bar charts show their actual emission intensity in these historical years. If you highlight each one, you can see what the emission intensity is. And then the green dot here is the target emission intensity in year 2029. The yellow line chart here shows the trend line of the blue bar graph data. And as you can see, CSX is very dependent on the transformative technology to close the gap between their trend line and their emissions intensity target in 2029. Down here in the bottom left, we can focus in on scope 1 absolute emissions for CSX. So the yellow, you can highlight each of the yellow historical years and see what the absolute metric tons of CO2 equivalent emissions were for scope 1 for each year. And then you can also see the absolute reduction from the base year 2014 as you highlight each year. The blue line shows the percent reduction from the base year. So if we highlight 2019, you can see that CSX has had 21.83% reduction in scope 1 emissions from their 2014 base year. And if you go over to the one to the right, this is focused on their scope 2 absolute emissions. The same with highlighting each one, you can see what the absolute scope 2 emissions were. And then the blue chart or the blue line graph shows your percent reduction. So since 2014, CSX has had a 40.3% reduction in scope 2 emissions. This is attributed to reducing buildings and facilities, upgrades to lightings and shop areas that operate 24/7. In future years, CSX plans to continue in this asset utilization efficiencies and investing in renewable electricity, as Meaghan mentioned. So this is just a focus and a look at the progress that they've made. So this, I believe, concludes our presentation. If anyone has any questions for Meaghan or myself, we'd be happy to answer those now.
Meaghan, Sarah, thanks so much. That is a very powerful message, I think, for the whole industry on how innovative that, the railroads can actually be in reducing overall emissions. That's really, really good infographic stuff. Thanks for that. Again, we do have a couple of questions, but I'm going to ask Emma to forward those on to Meg, to you and Sarah, because we're going to crawl into the next session. Okay. You'll see why I use the word crawl here in a minute. But we're going to go to the ecological protection. And then again, thanks again, Meaghan, Sarah. Good job.
Thank you. Thank you.